Thanks, everybody. So this is going to be a very hands-on sort of tutorial, as I think anything with D3 should be. So I'm not sure if you can read this very well, but please go and grab this. You'll find it perhaps a little boring. If you don't, I'm going to keep this up for a few minutes while I kind of give a bit of a pretty picture show of where we'll get to by the end of today. So grab that GitHub repo. And what we'll be talking about today is using D3 right within the Jupyter Notebook, as opposed to using kind of Python packages that write to D3 and put it in the notebook. We're actually going to be able to kind of do whatever you could imagine possibly doing in D3. We'll do that right in the notebook. So examples of highly interactive animated graphs with different elements and whatever you could imagine. You can do. Well, this is in the repo. We'll get to it. Other examples. I come from an architecture background, so sometimes I like to do kind of crazy random spatial things. So this is an example of kind of a space filling algorithm that I worked out in Python. I want to be able to see how it would look in JavaScript so that I can then kind of post it on a web page or whatever. So this is kind of a mix of Python code and JavaScript producing this space filling thing at the end. And you can see it kind of as the algorithm evolves. This part is in JavaScript. And then you can go in and manually tweak things if you want to afterwards. So things that would be very difficult to imagine doing in kind of our standard Python packages. And we won't be restricted to just D3. I'll be talking mostly about D3 today, but there are a lot of other kind of JavaScript. It's hard to see the washout there, but this is exploring a graph with Sigma.js, which is another kind of JavaScript package for looking at just only that graphing package, or graphs and nodes and edges. So it's a nice little package, and we'll just show how you can do that as well. OK, so has everybody managed to get the GitHub repo? Anyone struggling with it? We're good and back? Awesome. OK. OK, so this is what we're going to talk through today. We'll talk about why you don't want to do this, which is most of the time. We'll talk about when you might want to do this. We'll dig a little bit deeper than you would think into. Actually, just for a start, any show of hands, how many people here use D3 on a semi-regular basis? OK, that's roughly what I expected. How many people use Jupyter here on a regular basis? OK, yeah. So this is I'm glad I'm speaking to the right audience. So we'll actually dig into a little bit of what D3 does and how it will interact with your Jupyter Notebook. And so that means getting into the DOM. And then we'll go through. Those of you that don't use D3 right now, don't worry. There's an awesome collection of examples out there that you'll be able to cut and paste things and use, and then kind of figure out how to tweak them over time. Introduce you to those in the blocks setup. And then we'll dig into a couple of examples. Super simple example, which is odd. So we say, yeah, you can do all these magic things. And then I'm going to show you how to do a scatter plot. But we'll start there. And then we'll go through a couple other examples to show you kind of where things will get tricky. And then we'll finally get back into this you can do whatever you want kind of world. And we'll get into some discussion from there. OK, so why would you want to do this sometimes, but not all the time? We'll start with why you wouldn't want to do it all the time. Because most of the time, what you really want to plot is a scatter plot or some bar chart or something. And there are amazing tools for that. Sometimes what you want to do is just produce something to export to a web page or something. And there are great tools for that. You can use MPL-D3 or Bokeh or whatever. There are plenty of ways to do this for most of the things you'd want to do. So if you have a particular visualization that that's fairly standard, let's say, and for which there are kind of packages that will let you do that very easily, use those. Don't do what I'm about to show you unless you're really into D3. But sometimes you may actually just want to have that sort of flexibility. You might want to be able to, let's say, so for me as a data scientist, I often find that I spend 95% of my visualization time doing extremely simple things. And then I want to have one really good money graph that I want to be able to show at the end of the day that says, here's what this thing is. Here's the awesome part of this. And so I tend to spend most of my time doing kind of matplotlib type plots, and then really digging into one at the end. And so if you're that kind of person, this will be a cool trick for you to be able to have in your toolbox. It's also potentially handy, I think, in some cases, if you're working with a front-end developer who's doing some D3 things, and you want to kind of work through how that data flow is going to happen on your Flask backend or something, where you want to kind of integrate all of that into a Jupyter Notebook when you're starting out. This is one possible way to do that. And for some other things, you might find that you saw some really awesome graphic in a block somewhere, and you just want to be able to use that without doing much to it. In that case, that may also be a useful use case for here. But generally, this is not for your everyday kind of stuff. Maybe, probably not. For anyone who just came, who just got in, please download this repo. We'll go through it today. And just a little heads up before we dig in, I'm going to get into, for those of you who aren't D3 people, who aren't front-end developers, you might glaze over a little bit here for the first bit. Please stick with it as much as possible. It'll make it a lot more useful. At the end, I'll show you that we've developed this little library is a strong word. There's like a single script that kind of embeds a lot of the stuff that we'll talk about, so that you can fairly easily kind of add things and play with it. So if you get lost, just kind of stick with it as much as you can, and hopefully we'll make sense of it in the end. OK, everybody has the notebook, or the sets of notebooks everyone wants to dig in? OK. All right, let's start with the first one to look at is the Hello DOM notebook. And I encourage you all at this point, if you're using, to find the, you want to find the development tools part of your browser that will let you see roughly what you're seeing here. So this is in Chrome. I believe it's under it's under View, I think, and then there's something developer tools somewhere down in there. Firefox is a similar thing. Anyways, what this lets you do is see console outputs from JavaScript, which is really handy if you're doing any sort of debugging. It also lets you just kind of see what's happening. Yep. It's very hard to see there. I'm not sure if I can. Sorry. I'll try to, the important things within like you can't read these things, for example, or these. Yeah, that's probably OK. I'll try to like focus on the kind of key things you'll need. But just if you can get something in your browser that lets you see the DOM, that would be pretty handy. Does anyone know what I mean with this at all? I see a few nods. OK, if someone's lost and someone else is nodding, please help the person that's there. Yeah.
Can you zoom in on that so that we can see it on the screen?
Maybe. Here, let me. Oh, now you don't see this at all. Okay, sorry about that, guys. OK, so now you can see this is OK. In Chrome, if you go to View, Developer Tools, you should get something like this that pops up. This is looking at the console right now. If you look at the elements, you can see where the things are. This little handy trick, if you go to the this will let you kind of pick anything in the web page, essentially, and it will show you where that thing sits in the DOM. OK, so the DOM stands for Document Object Model. It's effectively, when you write HTML, you could think of it as you're writing a document that will be viewed, it'll be parsed and understood by the web page. that can be changed over time by your JavaScript. And so what D3 does, and what most JavaScript libraries do, essentially is you're modifying this DOM over time. So you can think of it as it's kind of an XML tree structure. You're going to add nodes. You're going to take away nodes. You're going to be doing things within the DOM. And so kind of being able to see what that means is pretty handy along the way here. Okay, sorry, if that's, just kind of move along here. What Jupyter has this one really kind of undervalued, I think, function that most of this talk is actually just going to be about, wow, look, there's this really cool function that gives you direct access to the DOM. And that is in the ipython.core.display module. There are a number of things that give you access to the DOM. The simplest one is this HTML function. And what that does, essentially, is if you write HTML followed by a string, it will interpret that string and essentially put it into the DOM right where the output of this thing here is. So if you kind of look through how this document is structured, you'll find that there are elements that correspond to the kind of the input field, elements that correspond to the output field. The output field that is the rendered output, that's where when you write in this HTML function, it will put that element into there. So you can write HTML strings. In this case, we're just writing a header with this particular text. It'll get interpreted as a header with that particular text in the DOM. Nice things you can add then too are you can add style tags to that. So you can start by kind of manipulating. So in this case, you have the same DOM element. We added a class to it. That class references a style. And so the style in this case is just giving the color of that DOM element. And lastly, you can add scripts that will modify this over time. So in this particular case, this HTML is just writing that to the DOM in this particular place as we did before. It's adding a style element. We're saying this is the class. I'm giving it an ID so that I can reference it from the JavaScript. And then the script. So originally, when I wrote that thing in there, I originally wrote in hello DOM, and then the JavaScript comes along, and it's going to change that text, in this case, to something else. So this kind of pattern of we're going to start with an object that we're going to put into the DOM. We're going to use JavaScript to change it. This is what we'll be doing throughout here. And so where D3 fits into all this, D3 is just a way of, it's a pretty clever library for helping you to modify the DOM with data. So the kind of pattern that gets used in D3 is you take, so you select a collection of DOM elements. So maybe you're selecting a bunch of headers, let's say. Through that selection, then you attach data to that. So now you have an array of elements that you've selected, and you have some array of data. We're going to then modify that array of elements based on that data. So it ends up super simple concept that ends up being extremely powerful within D3. And so that's what we'll be doing. We'll essentially be sending arrays of data that will modify the DOM through D3.
Should we expect to get the HTML blocks to render?
Yeah.
So if you just hit enter on that cell, is anything meant to happen?
If you hit enter everything above it, yeah, it should.
But like just the first cell where it's HTML.
Yeah,
Oh, that's
Oh, yeah, that's it. That's all
that's
it's.
all that's there.
That's all it's
I
there.
thought it was marked down.
Yeah. Is everybody else? Is the sheets working for everybody else? Okay. Okay. So then with D3, it's just JavaScript. Don't be afraid of it. And this is an example of the same sort of thing. We're going to start by adding some styles. We're going to use the styles in a div that we're going to add. And then we're going to add a script. And that script is going to specify some data. It's going to attach that data to everything of a particular type. So we're going to select some stuff, attach some data to it, and then we're going to change that that based on the data. So in this case, we're setting the size based on this data array that we had. So here we're setting the size of our string outputs. And then the kind of one last little step, which is a little bit quirky. What we'll do is to kind of connect this back to the Jupyter Notebook is we're actually just going to write our data from Jupyter into that string that we're going to send to the script. There are a lot of different ways that you could do this. In some ways, this is kind of the like roughest, jankiest way of doing it. But it means that this sheet that you now produce, this document, will work as expected when on NB Notebook or on NB Viewer. It just makes things a little bit easier if you kind of write it directly into the JavaScript. We can talk about it later if those want to talk about different ways of doing this, but this is the simplest way of doing it. So a little brief review. If you're lost, don't worry. That was the worst of it. It's going to get better. Essentially, this thing, this HTML, this is your friend. That's the main part. If you take away from this, that's what we'll be using, is that writing into the DOM. What we do with that is that it's actually adding DOM elements at that place in the notebook. We'll add style elements that let us change colors and such things. We'll be adding div elements, which then let us add SVG elements and other things, magic things within D3. And then we'll add scripts that will change that over time. And this is all great. Yeah, wow, but why are we writing text? I thought we were talking about visualization. This is silly. So this is, for those that haven't seen these things, they're amazing. You're going to love them. This is in the blocks world. So if you go to d3js.org, that's one way to get to them. You can see all these incredible visualizations of this and that and whatever. You can also just go straight to blocks. Mike Bostock has some pretty amazing ones. And you'll see what you get with these is usually a pretty picture of how the thing works. It's usually interactive. A little description maybe of what it is. And then you get code that you can actually just download, copy, paste, do whatever you need to do with it. And that should work right out of the box. So if you take a block, pull down the HTML, pull down whatever data is associated with it, put it on your desktop, click on that index.html, it will pop up in your browser, and boom, you have this thing. So this is what we'll kind of use to make this transition. We'll take some blocks. We'll figure out how to modify them a little bit so that we can use them in the notebook. And what's kind of nice about that is that there is this pretty amazing array of visualizations out there that if you might find useful for what you're doing. So our first example is a scatter plot. Sure, why not do a super simple scatter plot? This is from the iris data set that every data scientist has seen at least. We should do some sort of like graph of how often we see this thing. But so there's a particular block, this one here, and I'm actually just going to switch back to digging into the notebook here. So I can show you. And of course, I might not have internet working here. But this, if anyone does, you can just click on that link. It'll show you what the block looks like. And what we'll do here should be pretty obviously just kind of cut and paste. So we'll walk through this a little bit. Okay, so you'll see your main thing you need here, of course, is that awesome that HTML export. We'll also use the template command. There are also many ways that you could do this as well, but this is just to get our data into the string that we're going to write into the script that will get read by the HTML. I prefer to download D3 and use it locally. You could also just reference there's plenty of CDNs that host D3. The problem I'm finding with that is that if you use a hosted version of D3 and then you post it somewhere, it doesn't necessarily get viewed right away. Or if someone opens the notebook, it might be empty. Like the D3 things don't show up. It'll say D3 is not found, whatever. So it's best to kind of host it locally if you can, but it still works for what you're doing if you, for most of what you're doing, if you use the CDN. OK, so this case, this sepal length, this iris data set you can grab from one of a million different places, obviously. Here's one of them. We'll read that into a data frame. I guess one kind of trick of this is that usually most of those blocks you'll find are expecting that the data comes in a certain way. So you kind of need to match the data that you have to the data that's expected in that block. And so usually it ends up being an array of dicts. And so one kind of handy thing is just to take the in pandas, just use this toDict records. Will usually get you into the form that is kind of asked for in the D3 code. So from the blocks, did it load? No, it didn't load. If you just copy the CSV, so if you're looking at the block, you'll see the first part of it is there's a style tab or a style section. Essentially, just take that whole section. You can copy it into this area. The trickier one is the JavaScript part. So there'll be another kind of section at the bottom of the block that shows the JavaScript. Again, you can take that, copy it in. We'll talk later about other ways to make this a little bit less kind of janky, but it helps to see it here. A couple things that will change, just these widths. You can modify those to kind of better suit your screen resolution. If you get really fancy, you can actually reference the DOM element that you're writing to and then have it change the width accordingly. The other thing you're going to need to change when you go from a block to using this in D3 is that you'll need to, instead of, so D3 will be looking for a particular DOM element to write things to. And usually in those blocks, it's just looking for the body. It's just I'm going to add some stuff to the body. I'm going to add some stuff to kind of like whatever div it has set up. In this case, we need to add it to that particular element that we're going to write in the Jupyter Notebook. And so you'll need to go through and essentially find the D3 select, change that usually from body to something that will let you attach to it. It's one major thing. The other major thing is that usually the blocks will be referencing an external file, usually a CSV or a tab-separated file. And you'll see this sort of thing that says, read this TSV file, and then make this. This is a callback function. Those who aren't used to JavaScript, this is totally weird and wacky. But the reason that they do this is because everything has to be asynchronous, so that the rest of your page will still render and whatever. So what's happening is it's reading the file and then waiting for it to be done. And then once it's done, it's going to call this function. And that function is then going to reference whatever it read. In this case, that's that variable name. Usually it's data in the blocks, but not necessarily. So that variable name, we're just going to write our data directly to that variable name. And so you'll replace all of this stuff with this. And this, the star there, or the dollar sign, is just what we use in the template engine to find and replace that. So if you're just using the string template, which we are here, then that is just the variable name that you'll write into that. And that's it. Just one last thing at the bottom is usually there's that function had a closing, and you just have to make sure that you get rid of the closing. OK, so then once you've done that, so now you have this CSS text, which you've pulled. And that's just the styles of the thing. You have this JavaScript that you've taken in, and you've made a template of that. You've made those few modifications that you need to make to it. And now once you have those magic things, we have this, we're going to make another template for the HTML string. In this case, this ends up being pretty easy to standardize. So we're going to write some CSS into the style tab that we're going to add to the HTML. We're going to add a div. This is going to be the main thing that we'll attach things to. So instead of it being body in the blocks, it's going to be something that we give an ID that we can reference. And then we're going to write the JavaScript text. This is just the templating engine doing its thing. So you've got, we're going to overwrite that graph div in the JS text that we just pulled with the so that it matches our ID here. And the Python data, to be safe, we'll JSON dump that, dump it to a string. For most of the time, you don't actually need to do that. You can just write it as a string version of the array of dicks, and it should work out fine. And then there you go. You have yourself a, and apologies for the, there you go. You have a scatter plot, which you could easily have done in a lot less hassle with any of our existing tools. But as a pattern, yeah.
Why is JSON.dump sometimes safer?
Sometimes safer?
Why is JSON.dump sometimes safer?
So I mean, because you're writing to a string. So if you take the string version of a dict, it should work essentially, but not always. If you have, I'm not even sure why it doesn't sometimes for me, but sometimes it doesn't. Whereas JSON dump will write it into a form that JS is for sure going to be able to read. Yep.
Yeah, just there is a pandas data frame as a method to JSON, which you can probably use here.
Yeah, actually, yeah, that would also work. Instead of writing to dict and then from dict to JSON, you could just go straight to JSON.
I mean, I think that's what it's doing underneath it, right?
Yeah.
But it's one function.
Yeah, instead of two. Yeah, be nice. Yep. Yeah.
Is there any we can, because if you do it this way, essentially there's a string replacement of all the data that goes to HTML that gets rendered.
Yeah.
Is there any way to sort of dynamically adjust the graphics, the these three graphics? So, for example, if I have a web service that pump a bunch of data based on different requests with different parameters, is it possible to reuse sort of the diagram there?
There's kind of two parts to that. One is, yes, we can reuse parts of this, and I'll show you in the next one how that actually happens. D3 will update things. And it's a bit tricky in our context, but it does. The other part of that is, so right now, instead of writing it in as a text, which is a bit awkward, you could do a couple of things. One, you could just export it to a JSON file and then have it be read in, which is naturally what the blocks would do, would read in that JSON file. You could do that. What would be nicer would be to kind of more closely approximate what would happen in a server front-end sort of situation. I haven't really figured out a nice, simple way to do that yet, but it would be great if, essentially, if instead of writing into that text string, you could essentially, have that out at create an endpoint in some sort of server within Jupyter or something, like some sort within that framework that then gets hit by the JavaScript. I've yet to figure out a nice smooth transition, but if you have any ideas, it'd be great.
And would you recommend something like a Bower or something to keep track of your JavaScript?
Maybe.
Probably.
I don't know. Side thing, yeah. Any other questions before I move on? But well, that question of can we use this to update the next topic in the slides, and I'm just going to skip the slide because we'll go straight into it here, is actually just that. So remember that we've in the notebook we're used to thinking in terms of you make a block, it gives you an output. That output falls below it. You make another block, it gives you another output. Everything is kind of sequential. When you're writing JavaScript and JavaScript is referencing elements in the DOM, it might not necessarily reference always the one that you want. It'll actually just, you can find any DOM element and modify it, which is both scary and potentially amazing. So in this case, we'll use this. This is another kind of simple bar chart example. But I just want to use it to show this kind of updating feature. So the same sort of thing, we'll use the same libraries. We'll reference our JavaScript, or the D3 locally. This you'll recognize from the same thing that happened last time. Pulled this CSS straight from that blocks example, same way we did last time. The template is more or less the same as last time. You'll see the same pattern of changing this data. We'll write the data directly into the string again. Same change here, changing the div that we're referencing. And OK, this part we'll come back to in a moment. This is the update part. So we have some data. We start with this. Let's actually, for some, let's clear all the output here. OK, so we've just constructed some data. In this case, we have 4 letters. Each has a value of 1. It's pretty amazingly complicated data. It's a small data problem. And now we're going to create a bar chart with that data. And it looks pretty weird, just all ones. This is, by the way, nominally interactive in that you can scroll over it. That's just comes free with the blocks that we pulled in. Now here's the tricky part of this one. So we've created a. So this is what it did when it ran that, right? It wrote this script into that. First, it created a DOM element called div with a certain ID. It created that. Used this JavaScript to modify that. In particular, it's adding an SVG element, and then it's adding a bunch of bars or a bunch of rectangles to that element with this JavaScript code. Now, the update code, D3 has this one of the kind of great parts of D3 essentially is that if you have a collection of elements and you have some data attached to that, or even if you don't, if you attach new data to that, it will figure out is there now more data than there were elements? Are there less data than elements? And it will kind of give you this. If there's more data, you now have elements that are entering, and so you'll have this kind of enter. This is the stage terminology of things entering and exiting, and you'll update with that data. So what this is doing is it's selecting all of the everything of the class bar, which in this case is these 4 bars. It's going to select those rectangles. It's going to attach data to that. In this case, we're going to kind of update that data. So we're going to attach new data to that. And then we're going to add a transition that will change the height of the bar, change essentially how it looks in the y-axis with that new data. And so what this will do, once you run this last one, and actually just control, is that instead of creating a new DOM element, it's writing a script into that kind of DOM element below it that is referencing the one above it. So you're actually going back and you're changing that other DOM element that you had. So you can go to town on this all day if you want and just keep updating that DOM, which is potentially useful, potentially scary. So if you want this to not happen, you have to make sure that your DOM elements, that your IDs are unique every time you kind of add a new one. If you do want this to happen, you can. It's kind of nice. OK, so those are kind of the main concepts that we need to capture today. Are there any kind of, but then I'm just going to go through a bunch of examples to kind of reiterate on these things. and then show you the little library that will help you to kind of encapsulate this so it's not as ugly when you kind of write your JavaScript in. And then we'll talk a little bit about some pretty awesome things that are aside from this. But before we go into any of that, like, are the basic ideas reasonably clear to people? I like that thumb in the back. Is this super slow? Is everyone kind of getting bored of this at this point? I see a particular turn of the head, so I'm going to assume that we're doing the right thing. OK, so let's just walk through some of these cooler examples, which is ultimately what why we're bothering in the first place, right?
I have a quick question.
Yep.
Can you also put your block of JavaScript code in a separate file in case you get tired of editing JavaScript in Firefox?
Yep. Yeah. Oh, yeah. And it doesn't have the, yeah. That's part of the cute little library that we have that does that. Yeah, that's, yeah. You'll find in that repo, essentially, there's a JS folder, and it has a bunch of examples that are in that right now.
You just tell the template to read the file
Yeah.
instead of
Yep. Yeah, which, yeah, is just a lot nicer, usually. OK, so let's look through some cool examples here. Let's start with this one. Sure, why not? So this was one of the ones that when you guys were downloading the repo, I was kind of talking through. This one is a so monthly temperature histories from, this is a really, really big data set on AWS if you want to get it. There's a blog post where I went through kind of filtering that down to something that we could view. But essentially, we'll kind of use this as a test case here. In that particular, so it's referencing some data that's also in that repo on stations, and then for each station there are a bunch of temperatures for each month. It's all great. And then the way that the JavaScript, or the D3 example in this case, is set up kind of asks for the data in a certain format. So there's a lot of kind of munging to get it in that format. And then it's here. I'm actually going to show you this to you in Firefox, because for whatever reason, this particular one works better in Firefox. Usually works better in Firefox. Doop-de-doop-doo. And so this has a nice, animate feature. You can pull these things around. Oops. Probably not useful for your kind of personal scientific exploration, but potentially useful for something if you really want to impress a client or something, to be able to kind of give them this sort of access to something like that. I should show you this. So in this case, the JavaScript I didn't pull into the code or into the notebook because it's just far too long. You can see the JavaScript in the repo. So in this case, it's a lot more JavaScript than the kind of examples we've looked at so far, which is part of the kind of joys and downfalls of D3 is that you can do anything, and sometimes it takes a long time. But essentially, the same sort of thing we're writing into this SVG ID. Is that the thing that we're? Okay, so you'll recognize these sorts of things here. So we're writing the data directly into that, into the JavaScript that will get read in. So exactly the same pattern, just happens to be hundreds of lines of JavaScript instead of a few. But you can kind of see how that would work. There are plenty of other examples in that. Yep. Yeah. No. I've been playing around with that, and honestly, I don't understand the details of those two different things well enough to know when or why. I was hoping that I could loop over display. I can't loop over HTML, but I haven't been able to. And I should ask the Jupyter guys why they have the separate ones, but no, I don't think so. Yeah. Thanks for pointing. I meant to clean all this stuff up, but sorry about that. Let's go to, okay, so just an example. So the same principles, you can use other JavaScript libraries in the same sort of way. So this one is one that I just kind of recently was pointed to, called Sigma.js. If you are doing any sort of network visualization, it's a nice little package that works right off the shelf. So I'm, in this case, constructing a network fairly randomly, just kind of putting in nodes and edges. So this is what the kind of node table would look like and what the edge table would look like. And again, you can kind of dig into it's referencing this external JavaScript file. It's overwriting it in the same sort of way. And then you get this nice visualization. The handy part of this one is that you can kind of click on something and it will show you all its neighbors. There are a bunch of other kind of other things you can do if you really dig into this particular package to look at things. So things that would be tricky in kind of our existing libraries, there are often JavaScript libraries that are already kind of set up to do them. I'm going to leave you to look at the other examples if you want to kind of really dig in. There's this 3D meshing one, which is kind of fun, and this polyfill one, which is actually really fun to play with. Just re-hit that animation button over and over and over all day in the classic D3 way. Okay, so this leads us to this cute little set script that will make it so you don't have to write all this stuff in Jupyter. And essentially, what this is doing exactly the same things that we kind of walked through step by step. It's just doing it in a library. So I'll show you kind of where that with these examples. So there's a tiny little Python file that you'll find in the repo. You'll recognize all the things that it does because it does the same things. It's just there. It's expecting all of the CSS that it's going to read to be in a folder called CSS, and it's expecting all of the JavaScript to be in a folder called JS. And then what's, I guess, kind of nice about it is that instead of having all those lines of writing over templates and whatever, we could do it all in this one here, still calling the HTML thing. We're going to draw this graph. This case is going to reference basic line.js in the JS folder, read that in, overwrite it with, in this case, a randomized div label or div ID, so that we'll make sure that we have separate div IDs as we go down through the sheet. And then the data that you want to give it. So in this case, is expecting one overwrite in the text in the JS that has the name of data, and we're going to write it with our particular this data, in this case called data. So another kind of super simple line plot, scatter plot you'll recognize using the same data. These ones are kind of nice, the force-directed graphs. Sorry. So one thing I've been finding with this is that if you're kind of playing with this back and forth and you have your JavaScript in another text editor, you can go and change the JavaScript. So without changing anything in the Jupyter Notebook, you can change the JavaScript and then just rerun this one line. So in this case, let's say we wanted to change all these colors. We wouldn't have to do anything in the this is force directed graph. So you could make changes in this, in the JavaScript, go back and rerun it kind of iteratively back and forth. So you kind of keep your JavaScript on one side and your Python on one side and be able to go back and forth. In this case, let's just make those radiuses really, really big. Go back and rerun this. And voila, we have really giant, unfortunately giant things in there. More examples. So these are all just kind of simple examples pulled from blocks. Feel free to do the same. The pattern should be pretty easy to follow.
Good question.
Yep.
What does the force-directed graph actually show?
Okay.
Based on the original graph.
So it's showing the data just gives nodes that aren't localized in space at all. They're just giving it, just saying I have, in this case, 20 nodes, or how many 30 nodes. And then the data is defining edges between them. So it's saying that node 1 is connected to node 2 and node 4, and then so on, kind of down the list of which nodes are connected to which nodes. And that's all the data is saying. It's just saying I have a graph. These are the edges. These are the nodes. What this force-directed graph, and you can, this is a D3 specific kind of function that you can look through all the documentation of exactly what it does. But essentially what it's doing is it's taking the nodes and trying to scatter them, but you can imagine the edges kind of pulling them back together. And so it's simulating over time steps that process whereby things kind of get pushed and pulled in such a way that they end up spreading out, but like kind of naturally finding a way that you can view it that's that you didn't have to define before. So like the x and y points will kind of find their own way. And then the same sort of thing happens when you move it. It's just updating based on those kind of forces that it has. So that's why it's force directed. Yeah, it's just a kind of cute way to visualize graphs. Heat maps, whatever you want to get there. Okay, so I've managed to, everyone sees how you do this. You can go, and I can probably leave you alone now. There's just one, before we kind of get into final questions and discussion, there's one kind of main, more theoretical point that I'd like to kind of make, I guess, and then show you an example of this. So usually we think of visualization, and usually our libraries are of the type where you expect the user to select a type of graph, add some data to it, and then customize it in some way. So you now have, you can imagine a library of graph types. For each graph type, you have a number of different parameters. And so usually we kind of think of, I'm going to pick a line chart. I'm going to customize it the way I want. On the other hand, if you were a data visualization person in the front-end kind of world, or in a someone who's used to using Illustrator or that sort of thing, you're probably used to thinking more in terms of, I'm going to have some lines and some circles and some whatever, and I'm going to have them arrayed on the page in a certain way. You're kind of more, the level at which things are standardized are at a much lower level to give you a much broader array of possibilities. So within that world, instead of thinking of, I'm making a scatter plot, and then I'm going to customize it certain ways, you're actually thinking, I'm going to make something that has a line here and a line here, and it has a bunch of circles. Circles are going to be different colors in different places. if you're thinking of maps, you'd think of them the same way. You wouldn't necessarily be thinking in types. You'd be thinking at a much lower level. And so what using this sort of technique lets you do is lets you think at that sort of level. So if you are, if you have something that just doesn't fit any categories in your visualization at all, this will let you explore that. So as an example of that, I'd like to walk you through. There are a bunch of different tools with which you can make SVGs. Just back up 1 second for those who aren't D3 users, which I know most of us aren't. So SVG stands for Scalable Vector Graphic. And it's one of the main things that when D3 makes a graph, usually it's adding an SVG element, and then to that it's adding a bunch of these elements like circles and lines and rectangles and whatever. So those are all within this SVG world. SVG is not necessarily just like a JavaScript thing or a D3 thing. It's a way of describing a vector image more generally. And so if you use a vector image making tool, in this case like Illustrator, or there are plenty of other kind of open source tools that do that, you can have at it. You can have your free reign. So let's make, in this case, some sort of visualization involving boxes. Let's make a few of them. This presumably means something to someone somewhere. And let's add a bunch of circles. Cancel there. Now let's say that your project, for whatever reason, this was the thing that you wanted to get across. This was the important message, was something like this, and that, but these circles, A, they mean something, and B, they're going to respond to changes in the data. So this is kind of the thing that you're trying to get across. It has, I don't know what kind of name of type of graph I would give this thing, but effectively you could think of this is what I want to show. So if you save this as a save as an SVG, let's call it crazy. Okay, so now we have this SVG file, which we can open in a text editor, which is pretty nice. And you may recognize some of this as looking a bit like some things that we might be able to add to the DOM. That's effectively what D3 would do, is it kind of adds things one at a time. We can just go in and add these ourselves. So we can write this into HTML, everything except for that first line. You don't want to have that first line there saying it's XML. We'll take everything else. We're going to copy that into and I have an example of this already in here. Randomized sketch. So I had already done this earlier, but so we're going to write that in there. Just so this is writing what we just made in Illustrator into the HTML in the Jupyter Notebook, which is great. So let's just run that. And now we have in the Jupyter Notebook the thing that we just made in Illustrator, which is kind of cool, kind of crazy. I'm not sure why you'd necessarily want to do that, but you could think of other things you might want to do that would fit that sort of bill. And now what we're going to do is we're going to update that, because now we have it in there. We can use D3 or anything else to change that all the elements in that div. So in this case, I'm going to add some random noise. This is going to bounce around. And we're going to set the size of the kind of bounces with this data in Python. So in this case, we're going to say that the most it will go is 100 pixels in the x direction and 70 pixels in the y direction. This script here is just the set interval in JavaScript is just going to, every 1,000 milliseconds, is going to rerun this thing. So we're going to update at random these circles every 1,000 seconds, and we've got a transition, a D3 transition that will make it kind of smooth. So if you click on that, you'll see that your handmade SVG is now responding to changes over time. If you want it to stop, you simply make it stop. It's back to where you were. So this sort of idea lets you be as crazy flexible as you could possibly imagine being, and you're not really stuck to types of graphs. That's more or less what I wanted to show you guys today. There isn't really, frankly, it's pretty like, if you remember one thing, is that the HTML, the ipython.core.display.html is awesome, and this is why. That's pretty much it. Any questions? Any thoughts? Yep.
This is lovely. Forgive me for saying I see a lot of boilerplate in all these HTML codes you're doing.
Yep.
Repetition.
Yep.
Has anyone thought of writing a toolkit for automating that?
In terms of like taking a block
Or just
and
like more like a nice API that spits out all these repeated patterns of HTML and JavaScript that you use with steer D3.
yeah, beyond the little thing that we wrote kind of for this and that we use internally, I haven't seen anyone do that, and I haven't done anything like that myself. It's probably worth doing. I do think that there are better ways to do this that are kind of more robust and that would be more, it would look more like the kind of server front-end interaction that you'd expect. So I think that there are kind of, if one is to write a library, they could probably do it better than what we've kind of put together so far. But there is a rudimentary version of what you're asking for, I think, is in that repo that kind of does that to some extent. But yeah.
To respond to your question, I found randomly on GitHub there's something called MPLD3,
Yep.
which acts as backend matplotlib. So just render all your things in D3, and then you can do all the fancy stuff.
Yeah, and I should note, Bokeh as well will export, HTML that you can read in the same way. So if you go to
The exports canvas, not SVG.
yeah, that's true. But so if you look at kind of the MPL D3 export, it does it's a D3 file that you could then possibly manipulate. It's pretty verbose.
That's still being maintained. Something. It
What's
doesn't
that?
seem like it's been updated in a while.
I'm not sure what's happening there. But.
Want to fork it and run with it?
But again, those are of the pattern that you're kind of making a type of graph and then you're modifying it to suit, as opposed to taking a D3 visualization and then modifying it in Python. Yep.
Are there any reusable D3 sort of libraries that you find interesting, like an NVD3?
Some of the guys in our office use NVD3.
Okay.
I personally, that is generally a problem with D3, is that it's so flexible that it's hard to kind of make it reusable. Really the most, and I've tried myself to like make more reusable versions of it. And sometimes you can do some things that are where you kind of like encapsulate little bits of it, but almost inevitably you will want that lower level of functionality that any kind of encapsulation would limit somehow. So yeah, there are people have been wrestling with this for a while, and there are some solutions, but I usually just to stick right with the D3, and it sometimes means that you do a bunch of more copy paste than you'd want and whatever, but it still ends up being pretty useful. Okay, cool. I'll stick around for a while if anyone wants to have any questions. You should check out our blog. We've got some really cool stuff on our blog. And yeah, find me if you have any questions.